Hi guys, maayong adlaw. Welcome to NatzMath TV. So for today's video, my presentation is about simplifying radicals. This is now the first lesson about radicals. Soon I will be presenting to you about performing operations with radicals. But before that, please do not forget to subscribe, like, and share to your friends, especially those who are incoming grade 11 students, and of course for the junior high school student. This lesson is for grade 9 students. So to start, a radical is denoted by this expression, the nth root of a, where n is called the index and our a here is called the radicand. And this symbol is called the radical symbol. Now, if ever in a radical expression there is no index indicated, it is assumed that the index is 2. That's why it is called a square root. Before we proceed to our example, let us have first these different numbers or numbers which are perfect squares. So we have here the column for the radicals and its square roots. So these numbers here are what we call the perfect square numbers. So we have here square root of 1 until square root of 400. But it doesn't necessarily mean that these are just the numbers which are perfect squares. There are numbers greater than 400 which are also perfect square. For the sake of this presentation, we will have until 400. So these numbers 1, 4, 9, 16, 25, and so on are what we call the perfect square numbers because when we say the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. That means that when we multiply these numbers twice, we will get these numbers here. For example, we will multiply 1 times 1, that will give us 1. 2 times 2, that will give us 4. 3 times 3, that will give us 9, and so on. So we should be very familiar with these numbers because we will be using this one in simplifying radicals. Okay, to proceed with the examples. For example, you are told to simplify square root of 50. So how do we simplify square root of 50? With the perfect square numbers in our mind, we have to factor out 50 in such a way that one of the factors will give us a perfect square. So, meaning 50 can be written as 25 times 2. Why? Because 25 is a perfect square, then multiply that with 2, that will give us 50. So we did not change the value of the radicand. We just simply factor out the radicand in such a way that one of the factors will give us a perfect square. So in this case, we have 25 times 2. Now, since 25 is a perfect square, so we can get the square root of 25, which is 5. And we place 5 outside the radical symbol, so our final answer becomes 5 times the square root of 2. So the 2 here shall remain at the radicand since it is not a perfect square. And we can no longer simplify 2. So therefore, our simplified form for square root of 50 is 5 times the square root of 2. Another example. For example, we are told to simplify square root of 48. The same concept. We need to factor out 48 in such a way that one of the factors will give us a perfect square. So in this case, we can write 48 as 16 times 3. Since 16 is a perfect square, and multiply that to 3, that will give us 48. And 3 is not a perfect square, so 3 shall remain at the radicand. So when we get the square root of 16, that would give us 4. So we place now 4 outside the radicand because we already have extracted the square root. So what shall remain at the radicand is the square root of 4. So the simplified form for the square root of 48 shall be 4 times the square root of 3. Another example. This time we have now the cube root. The same concept, but this time 16 is a perfect square but not a perfect cube. That's why we cannot get the cube root of 16 directly. So the same concept, we can factor out 16 by writing 8 times 2. How do we get the cube root of 8? We find a number that will be multiplied thrice will give us 8, and that number is 2. So when we multiply 2 3 times, that will give us 8. 2 times 2 is 4. 4 times 2 is 8. Therefore, the cube root of 8 is 2. Then we place 2 outside the radical symbol. So our final answer would be 2, which is the cube root of 8 times the cube root of 2, since 2 is not a perfect cube. So our final answer for the cube root of 16 is 2 times the cube root of 2. Another example, how about we are given the fourth root of 80? The same. We need to factor out 80 in such a way that will give us a number which is a perfect fourth root. This time we can have the fourth root of 16 times 5. Why? Because 16 times 5 is, of course, will give us 80, and 16 is a perfect fourth root. We need to find a number that when multiplied 4 times will give us 16. And in this case, our number is 2. So when we multiply 2 4 times, that will give us 16. So for example, 2 times 2 is 4, times 2 is 8, times 2 is 16. So therefore, the fourth root of 16 is 2. So we place 2 outside the radical symbol. So we have here the 2, which is the fourth root of 16. Then we copy the fourth root of 5, since 5 is not a perfect fourth root. Now let's proceed to another example. For example, you are given the cube root of a raised to 11. Now this time, since we are given a raised to 11, what we need to do with the radicand is just simply factor out in such a way that the exponent of one of the factors shall be divisible by the index here. In this case, our index is 3. So therefore, we can rewrite a raised to 11 as the cube root of a raised to 9 times a raised to 2. In this case, when we multiply a raised to 9 times a raised to 2, that will give us a raised to 11. And in this case, also 9 is divisible by 3. So therefore, we can extract the cube root of a raised to 9, placing it outside the radical. So we can rewrite this one as a raised to 3. How did we get 3 here? We just simply divide 9 by 3. And what shall remain in the radical shall be a squared. So our final answer shall be a cubed times the cube root of a squared. Another example, say the square root of y raised to 9. The same concept, we factor out the radicand y raised to 9 in such a way that the exponent of one of the factors will be divisible by the index. In this case, our index is 2. So therefore, we can rewrite this one as the square root of y raised to 8 times y, because it has an assumed exponent 1 here. Y raised to 8 times y will give us y raised to 9, and 8 here is divisible by the index 2. So therefore, when we extract the square root of y raised to 8 will give us y raised to 4, because we divide 8 by the index here, which is 2. So 8 divided by 2 is 4. And what shall remain in the radical shall be the square root of y. So the simplified form for the square root of y raised to 9 is y raised to 4 times the square root of y. So this is now our final answer. Let's proceed to another example. For example, we are given the square root of 4x squared. As you have observed, 4 is a perfect square, and x squared, we have here the 2, which is divisible by the index 2, so therefore this is a perfect square. Both 4 and x squared is a perfect square, so therefore when we extract the square root of 4x squared will give us 2x. That is the square root of 4, which is 2, and the square root of x squared, which is x, because when we divide 2 by 2 in the index here, that will give us 1, and x here is assumed to have 1. Okay, another example. For example, we are given the square root of 50 a cubed b squared. Okay, the same concept. We factor out 50 a cubed and no problem with b squared because we already have the 2 here, since b squared is already a perfect square. So we just simply factor out 50 by writing 25 times 2, which is 50, and a cubed can be written as a squared times a, and we just simply copy b squared. So we have here the 25, which is a perfect square. A squared is also a perfect square. B squared is also a perfect square. So when we get the square root of these numbers, we will have the square root of 25 is 5, the square root of a squared is a, the square root of b squared is b. So what shall remain inside the radical shall be the square root of 2 and a, because 2a is not a perfect square. So our simplified form for this expression shall be 5ab times the square root of 2a. So this is our final answer. For example, we are given the cube root of 8n raised to 6m raised to 4p raised to 2. 8 is already a perfect cube root. Then, since 6 is already divisible by 3, but 4 is not divisible by 3, so we need to factor out m raised to 4. So this shall become 8, which is a perfect cube, times the n raised to 6 times, this is m raised to 4, so we have m cubed times m. This is assumed to have an exponent 1, so m cubed times m, that will give us m raised to 4, and we just simply copy p squared. Then extract the cube root. The cube root of 8 is 2. The cube root of n raised to 6 is n squared. We copy the variable n, then we divide 6 by 3, which is 2. Then this time we have here the m cubed. So we copy the variable m, then 3 divided by 3 is 1, so it has an assumed exponent 1 here. Then what shall remain in the radical shall be the cube root of m, which is this one, since this is not a perfect cube, and also the p squared. So the simplified form for this expression shall be 2n squared m times the cube root of mp squared. For example, we are going to simplify the square root of 24x raised to 7. So we factor out 24 in such a way that one of the factors will give us a perfect square. So the factors are 4 times 6. 4 times 6 is 24, and 4 is a perfect square. And this time we have the x raised to 7. We factor out x raised to 7. That gives us x raised to 6 times x, since x is already divisible by 2 in the index here. So we get the square root of 4 and the square root of x raised to 6. So that gives us the square root of 4 is 2. Then we copy the variable x. 6 here is divided by the index, which is 2, will give us 3. What shall remain in the radical is the square root of 6x, because these numbers are not perfect squares. So this is now our final answer. Another example. This is now our last example. We have the square root of 25a cubed over 36b squared. This time, 25 and 36 are already a perfect square. Also, b squared is also a perfect square. So we just simply factor out a cubed. So we can write this one as, we copy 25. A cubed can be written as a squared times a over the 36 times the b squared. Then we get the square root. So the square root of 25 is 5. The square root of a squared is a, because when we divide 2 divided by the 2 here in the index is 1. So naanay siya assume 1 diha. Then over the square root of 36 is 6, and the square root of b squared is b. So what shall remain in the radical is this one, which is the square root of a, because this is not a perfect square. Okay, that's it. I hope you have learned something from this video. So for your comments and suggestions or questions, you can write in the comment section below, or you can send me a message through my Facebook account, which is found in the description box. So thank you and God bless.